This demo shows the effect of a propagation delay and how it can be used to build a ring oscillator. Now let's think about an inverter. An inverter, the input is high, the output is low, and vice versa. Now this is the ideal behavior, but a non-ideal behavior has to show some propagation delay, because when you try to switch the input, the output takes a certain amount of time before it also switches, and that's called the propagation delay. It may not match as it goes up and as it goes down, so these times from here to here and here to here may not exactly be the same. Now if I put two together, this output of this inverter goes into this one, then the A and the A prime should be the same. So the ideal behavior looks like this. In an actual circuit, though, it doesn't. So I want to show you an actual circuit. So let's look over at this circuit right here. What I've shown here, what I've built, is 3 inverters, and the first one is made out, all of them in fact are made out of transistors. Now we didn't use a MOSFET because that's too fast and we couldn't catch the propagation delay with this data acquisition board, so we needed to slow it down, so we used these power inverters or power transistors because they act kind of slow. They've got a larger propagation delay. So what we have here is I'm measuring the input to the first transistor. So this is the input right here. The first transistor is there. This is the input of a square wave into that first transistor. I'm measuring that first transistor, and then I'm measuring the output of the second transistor. So let's look at this. This is the green. This is the input to the first transistor, first inverter, and then this is the output of the second one. Now again, ideally, these should be lined up with one another, but you can see the effect of the propagation delay, and you can see that they're not equal going up and going down. The leading edge and the trailing edge are not necessarily equal. Now we're going to build a ring oscillator where we put 3 inverters together, and ideally if this is a 1, this would be a 0, this would be a 1, and that would be a 0, and that would cause a short across here because you've got a low connected to a high. But because of the propagation delay, once this goes high, there's a certain amount of time before this goes low, and that propagation delay is seen for each of these inverters. So there's actually quite a bit of time delay between when this goes high and this goes low. And the effect of putting a feedback loop on here makes it an unstable circuit. So we've got a time delay coupled with a feedback loop making it unstable. So I can take off this input, this external input, and have nothing connected to this but this, what you see here, so no other external input, and it will be unstable, causing this to go up and down or oscillating. So let's look at the actual response that we see with that. If I go back to this circuit and I pull off the external input, and I'm going to take this and show it as the output of this third transistor. So I'm showing the output of the second transistor and the output of the third transistor. And if I run this, okay, I'm running it. There's no external input to this one, and I'm seeing it oscillate. Again, this is the output of the third transistor of the third inverter. This is the output of the second inverter. It's going up and down. It's oscillating even though I have no external input. Again, that's due to the fact that I've got a propagation delay and a feedback loop around all of them, creating this oscillator. All right, thank you.